Okay, so yesterday Google shipped their even newer version of Gemini 2.0 Flash that contains reasoning traces or chain of thought traces in here. So they're calling this Gemini 2.0 Flash Thinking. It's an experimental model that's just been dropped now. One may think that it's been dropped quite deliberately to preempt a big announcement from OpenAI. Anyway, as I'm recording this, there is no fancy blog post about this or really many even details about this. It's kind of released on Twitter by a number of people on the Gemini team, starting with Logan Kilpatrick, who introduced the model and has got a nice little video example of it. Now, not long after Logan's post, we saw a whole bunch of posts from people working on the Gemini team, people like Jeff Dean, who's one of the two leaders of the Gemini team, talking about this model, talking about that it's like their first foray into this idea of building something where it's been trained to use its thoughts to strengthen reasoning in here. And it's kind of interesting to see that there is no sort of subterfuge in here, that they quite openly talk about that this is basically where they're increasing inference time computation, and that it's the first model that they're releasing like this. Really, this is not surprising for people who follow the research. DeepMind has had a number of papers around these ideas over the past couple of years, including this one, which was scaling LLM test time compute. And there've been others along similar lines to what OpenAI has been working on. Another thing, if you didn't know, some of the key people behind O1 at OpenAI are ex-Google Brain researchers. So it's really just a matter of time until when Google was going to release a model like this. One of the tweets that I found really interesting was Noam Shazia. For those of you who don't know, Noam Shazia is the guy that Google paid a fortune to bring back from Character AI. Him and his co-founder both were researchers at Google Brain in the past. They've come back now to Google DeepMind. He's also the key author, I would say, on the original Transformer paper, as well as many of the papers around mixture of experts and scaling to large models, inside Google. Now, very interestingly, not long after the Google tweets came out, we saw a tweet from LLM Arena, which is the place I've talked about many times where people go to test out their models, companies upload their models, etc. And we can see here that they're basically ranking this Gemini 2.0 Flash Thinking as tied for the #1 overall model with another experimental model, which no one has publicly confirmed exactly what it is. And I think we'll have to wait another month or so before we actually see that. So it is very interesting looking at the chatbot arena results that they're ranking this flash reasoning or flash thinking model above both O1 Preview and O1 Mini, which is interesting because don't forget, this is, built on Flash. This is the sort of much smaller, faster, more agile model. And it does really open the door for, okay, where do things go from here with the Gemini 2.0 models as they bring out Pro? Are we going to see Ultra come back for public use, etc.? And most of all, the probably biggest and coolest thing about this announcement today is that you can go and use this right now, and it's not going to cost you a penny. You don't have to pay $200 a month. You don't even have to pay to use it as an API. You can literally come into AI Studio, scroll down to the preview models, and access this Flash Thinking experimental. So the 12/19 date there. Currently, you can use this for free. Currently, the version that they've released only goes up to 32,000 tokens for the context window. I think we'll see that change early next year. But anyway, let's jump in here and have a look and play with just using this model. And let's see what it can do both in AI Studio. We'll also have a play with it of how you can use it on Colab via the API directly. Okay, so let's jump in and look at the first example. So I've got no system instructions in here, so I guess we're just going with whatever the default they had in there. And so obviously the first thing to ask is about the strawberry question. But if you see me do this in some of the other like reasoning models and stuff like that, nowadays what I ask is I spell strawberries wrong. So it's got 4 R's, and then I ask it, so how many R's in strawberry with spelt wrong? Should be 4. It actually gives us 3 in here. And we can see that it rephrases that, okay, I want to know just strawberry. Now, the thing that I thought was interesting was not that it gets it wrong, but I thought that I ask it, okay, that is not what I asked. Read my first statement carefully. And this is the bit that I find really interesting in here, is that in its sort of chain of thoughts, it now breaks down that, okay, identify the core issues. The user pointed out my mistake and specifically referenced their first statement. This tells me the problem isn't with the counting itself, but with understanding the input. This, I think, is really powerful, right? That it's having the ability to distinguish that, okay, it wasn't that the counting it got wrong, it was that it misinterpreted what I asked. And then now it looks at it and it noticed the misspelling of strawberry, right? That actually I spelt it wrong. And that was quite deliberate. So now it says, okay, let's go and sort of count, that. And so it now works out that, okay, there are 4 R's. So then it constructs a clear and concise answer, acknowledge the error, explicitly state the correct word I should have been analyzing, provide the accurate response, refine the answer, and then it gives us the answer back, right? You are absolutely right. My apologies. I misread your original statement. Counting the R's in strawberry, there are 4 R's. So whether this got this right or wrong is not the bit that I'm most interested in. I'm interested in these internal chains of thought. Now, by the way, check this out. If we were doing this with O1, we wouldn't have access to any of these. In this model from Google, we're getting the full output that it's basically doing its chains of thought in here. We're not getting some kind of abbreviated thing the O1 preview, etc. had. This is the full output for each of these statements. I do find it very kind of funny or ironic that when we ask the exact same model from the non-thinking thing and I spell it wrong, it straight away just says there are 4 R's in this. So it's almost like this thinking one is trying to understand your input more and think that, okay, you probably didn't mean to spell it wrong, but is then able to correct when it sees this issue. So for me, this one is really fascinating looking at this part in here. All right, let's look at another one. Okay, so this is a pretty simple sort of question. My mother was 24 when I was born. How old was she when I was 1/3 her age, half her age, and 3/4 her age? All right, so you can see that it gives us an answer back. This answer back has got explanations in it. So actually we've got quite a lot in the answer back here that sort of explains the thinking down to when we get the summary. But this is not the chain of thought thinking, right? So when we click this, we see the raw chains of thought that are going on in here. So we can see that here it's gone for understand core relationships. The fact is the age difference between mother and child remains a constant. Define variables. So these kinds of chains of thought, actually, a lot of them come out of some of the ideas around papers that came out of DeepMind for things like self-discover and prompt breeder and stuff like that, where they were trying to encourage models to come up with better and more useful chains of thought as they go through. So we can see with each of these, we're getting like what the chain of thought is, and then the actual thinking, behind it as we go through. So we can see that it comes through this. It does like a self-correcting or double-checking process. And here I find it very interesting how it actually asks itself questions about its own thinking here. Does the age difference remain constant? So it's looking at this. Do the answers make sense in the context of the problem? Read the question carefully. So it really is like it's double-checking its thought processes before it goes on to solve this. Then it goes on to show us the sort of answer or the proof of what it's actually done here. Okay, so the next one is like a variation on one I've done before. I do think it's really important that when you do these kind of things, in this case, I'm getting it testing, okay, does it understand the relationships between number of sisters and brothers? But we don't want to always go with Sally or the standard sort of way that these questions are formatted, because everyone's training on the internet. Those questions get out there. It's very easy for these models, even ones with no sort of self-reasoning, to be able to get good at memorizing answers. So here I've changed it to Freddie has 5 sisters. Each sister has 4 brothers. How many brothers does Freddie have? All right. So we can see that this is going off. We can see the amount of seconds it's taking to do the thinking, right? As it's going through, we can see clearly this time it's taking more seconds than the last one. All right, it's come back. It's given us its breakdown, focus on, and this is like the summary. This is what we would get from the output of the O1 model. So it's like a summary of its thinking. Okay, focus on the sister's perspective. The key piece of information is that each sister has 4 brothers, shared brothers. And sure enough, it's worked out that, okay, Freddie's brother, since Freddie is one of the brothers, he has 4 minus 1, which equals 3 brothers. Now, if we look at that chain of thought, we've got quite a lot of chain of thought going on there. So this is very interesting to actually be able to access this raw sort of stuff. Again, I point out that all of this is free, right? You can use this now already in AI Studio. AI Studio is definitely aimed at developers, but I know a lot of you who are watching are perhaps not developers. You can come along and just use this for free. It's not hard to use. Remember, you can just always come up here, make an API key, get your 1,500 free calls a day or whatever it is that you've got access to in there. Looking at this again, we can see that, okay, we need to identify the key individuals, focus on the sister's perspective, consider the shared brothers, connect Freddie to the brothers. There's a lot of nice chains of thought here that have come out of sort of step-by-step thinking of how to make this work. And even reread and confirm. So you can see that as it's going through this, it's putting it together to come up with the final answer. All right, let's look at one more before we have a quick look at looking at code for this. Okay, so the next one up is one that I've used before also in the videos, explain the consequences of what would have happened in World War II if the nuclear weapon wasn't used. So really this is testing it on how can it think of different sorts of possible futures, etc. Now, one of the issues that we've gotten here is that this may have been affected by this sort of content filter. And even though I've got all of these turned off, it flagged it in here. All right, so we can see here that we got some of the thinking that was very similar to some of the nice thinking from both O1 and R1 was like that, okay, that perhaps Russia would have got involved more and different things that could have possibly happened in here. So we definitely got a nice detailed out. If we look at the expanded chains of thought, we can see that, okay, what's the core question? Again, this is a very common pattern that these things do, is that they really have their first chains of thought that are all about trying to understand the question better. What did the person really mean behind this? And this is why I thought it was interesting when it got the strawberry wrong the first time, that it just presumed that, okay, that's a typo, he doesn't mean that, as it tries to understand the question, but was then able to correct that when I established, no, that go and read that because I didn't have a typo. Go and read it carefully. We can see that then we've got different sorts of things about brainstorming. So this is idea generation rather than just analysis of these things. This is now starting to think about, okay, coming up with ideas and then focus on most likely or discussed scenarios. Now, remember, this has been trained on a lot of the content on the web. So it's probably looking around at things in its training data, right? Not literally looking up things, but through its weights, it's going back to so what scenarios were proposed that it's read on the internet before. And then we can see it does some really interesting thing. Then it goes into sort of like analyze mode of where it analyzes each scenario in detail. And it asks itself specific questions about each scenario, that how would it unfold, consequences, evidence and arguments supporting the scenario, potential counter arguments and limitations. So there's some really nice sort of logical thinking going on in how it's doing these things. And then finally structuring its explanation out, refining, elaborate. I'm guessing at the end it's going to check, did it get it right? Yes, sure enough, we've got our self-correction example. And then it notices, okay, initial thought was focused solely on invasion, correction, realized that Soviet entry was a significant factor, and go through this. Now, obviously, if we're going to ask it something that Google's going to block heavily, we're probably not going to see that in the chains of thought coming through here. And it seems like this is just a warning. It hasn't actually taken anything out of the chain of thought from what I can see. And the answer seems very thorough as well going through this. Okay, so the next thing that I wanted to point out is that because Flash can take multimodal inputs in, we can do things like have it reason on images. So here you can see I've basically given it a puzzle where it's got a sort of unfolded die that can be assembled. And when it's assembled, it's going to be one of these. Now, notice that here I've put think carefully and hard. Then I'm just asking it, which of these die can be made with the layout in the pick? So it goes on to get the correct answer. If you look at this, you're going to basically end up having the square next to the 3 in this. These two can never be next to each other. So that eliminates these two. And then these two can never be next to each other because they're on opposite sides. So the only correct answer here is D. If we look at the answer out here, is that it gives us the correct answer. But more than this, when we're looking at the chain of thought, it's really got an interesting way of getting this, that it thinks about, okay, how these would go. And then it does a nice reevaluation of putting these, together. It talks about visualizing the folding. So where each piece is going to be on the folding and stuff like that as it goes through. Finally, it's able to come up with its final answer for doing this. So the whole idea of multimodal reasoning is really interesting as well. And that's one that's only just come to the O1 models with their recent release that can basically take images in. You could imagine that we could also get this to do reasoning on other multimodal things like audio, like video, that kind of thing going forward. Okay, let's just jump in and have a look at how you can do this directly via the API and how you can set it up for both text and for image input. I'm just going to quickly go through this and show you how to basically get started. So you're going to be using the GenAI Unified SDK. So this will work for both AI Studio or for Vertex AI. If you're using Vertex AI, you basically just don't pass in this. You will pass in a project, you'll pass in some IAM, some other stuff going on in there. First off, just calling a simple prompt, you'll see that, okay, the system prompt does actually have quite a bit of effect, I noticed. I'll talk about that a little bit more as we go through. But I've just started off with a simple system prompt, be a thorough and helpful assistant, explain the concepts of World War II. So I did that already in AI Studio. And you'll see that if you just take the response.txt, you get everything out here, right? The full sort of long thing. But if you take different parts, you can get the thinking, and then you can get the final answer as separate parts out. Now, interestingly, they have a .thought thing in there. So I'm not sure if later on that's going to become the thinking part will go in there so that we can get the thought out. At the moment, it doesn't seem to be being used in here. The next thing is just putting it together in a function. And in this case, I'm going to basically return back the full response, the chain of thought thinking, the final answer. And you can see now we can take, the Jenny has 5 brothers. They each have 3 sisters. How many sisters does Jenny have? I run it through with a system prompt of nothing. And you'll find that, okay, it gives me, this is a classic riddle. The answer is 2. It gives me the chain of thought thinking of why it came to that answer. And then we can get the full response. Now, interestingly, playing around with it, if I use this, keep your final answer succinct and very brief, that does seem to sort of limit both the final output, but also the actual quality of the chain of thought in just a few couple tests. So it could be coincidental. Put it in there and try it out. I definitely noticed, another one I'll show you in a bit, is that if you say, hey, take your time and think carefully about this, it will really use the chain of thought more in that way. So the system prompt definitely seems to influence both the chain of thought and the final output that you get there. The other cool thing is you can do this with images. So this is just bringing in the standard image that they've got, but you can bring in any image that you want. This is the jetpack backpack. It's a picture that's been used for Gemini for a while. And here I've just made a version of the get thinking with image, and we're just passing in the image as well into the prompt. And now I can ask it things like, how much weight do you think jetpack like this could carry? Think extensively. So this one I found it to be quite good. Comparing this to not passing in or passing in an empty system prompt, it got much better results. And you can see here, we've got the final answer back there. And then we've got the chain of thought showing the in-depth thinking that it's gone to. And then obviously the full response, putting it all together. So have a play with this. I definitely found this really interesting to try out. I've tried it on a few different agent tasks that I've been using. And it's quite nice for doing the planning and stuff and being able to abstract out, getting the chain of thought thinking for a plan and the final plan can be really useful to separate those out. Anyway, I will certainly be playing with this a lot more. I'll probably make some more videos with it over the next few weeks or when the GA version comes out so that we can look at that. As always, if you've got any questions or comments, I'd love to hear how you're using it, what you're finding it to be good at. I think the Gemini team would also love to hear where it's not doing well, so that if you can give feedback about that, that's also really interesting to see. And as always, if you found the video useful, please click and subscribe, and I will see you in the next video. Bye for now.